Okay, having a look at example 1.10, we're going to sketch y equals x log to the base ex. So let's start off with our x-intercepts. Okay, for our x-intercepts, we'll let y equal 0. So therefore, we'll have 0 is equal to x log to the base ex. All right, so here, we're going to split the function in two. So we've got the product of two separate functions here. So x would equal 0 from the first part here, so x is equal to 0. Now we must also solve when log to the base x is 0. So here, if I were to rearrange this, I can actually write this down the front, so I'd have x is equal to e, and then over here is the power to the power of 0, so x would equal to 1. So I'm going to have two x-intercepts, one at x equals 0, and 1 at x equals 1. So this one here will actually be the origin because y equals 0. Now, I'm going to find, well, that'll be the only y-intercept here actually, because when I let x equal 0, so I'll get y is equal to 0 multiplied by ln 0. Okay, so that'll be just 0. So I'm only getting 1 there. All right, so if I were to derive this now, so I've got y is equal to x. I'm going to rewrite it as just ln x. So here I've got a product of two functions, so I'll let u equal x. So deriving that would be 1. V here would be ln x. And deriving v would be 1 on x. So I'll go insides and outsides. So here the first derivative would be if I go u and the v dash, okay, I'll have x on x plus just 1 multiplied by ln x. So this would be 1 plus ln x. And that's the first derivative. Now, to find any stationary points, I'm going to let that equal 0. So here I'll have 0 is equal to 1 plus ln x. So I'll take the minus 1 or the 1 to the other side by minusing 1 to both sides. ln x is negative 1. Now remember this is log to the base e. X is negative 1. So here I'm going to have e, and then the power of minus 1 is equal to x. So therefore, I'm going to have a stationary point at x is 1 on e, or e to the negative 1. Now, to actually find the y coordinate, so at x is equal to e to the negative 1, I'm going to sub that into the original. So I'll have y is equal to e to the negative 1, ln e to the negative 1. Okay, so that would be 1 on e, and then I can actually, using my log laws, take this down the front. So then I'll have multiplied by negative 1, and then I'll have log to the base e. Now that would become 1. So I'm actually going to have the y coordinate here of negative 1 over e, or you could write it as negative e to the negative 1. So my stationary point is 1 on e minus 1 on e. Now let's determine the nature. So for determining the nature, I can look at the second derivative. So here I'm going to go y. So remember y dash was 1 plus ln x. So the second derivative here is actually quite easy because the constant here will become 0. So here I'm just going to get 1 on x. Now I'm going to substitute our x value of 1 on e into this equation, and then I'm going to look to see if it's positive or negative. So here I'll have the second derivative at x equals 1 on e as 1 over 1 on e, and then that would be just 1 on e. Now e is approximately equal to 2.7, so that's a positive number, so it's 1 over 2.7. So therefore, y double dash is greater than 0 as 1 on E is greater than 0. So therefore, the point 1 on E, negative 1 on E, is a minimum turning point. Okay, so if I were to sketch this now, now there is a restriction actually in the question, okay? I'm never going to have x being negative, okay, because in here, x must be greater. Okay, so that means the left-hand side, I'm not going to have anything there. I have my first x-intercept at the origin, 0, 0. I then had my next x-intercept at 1, 0. And I'm going to say that this here is our stationary point, our minimum point. Now, if I actually consider the original equation, when x gets really large, okay, I'm going to have a really large number multiplied by an increasing positive number as well. So that means it's actually going to look a bit like a parabola, and it's just going to go upwards. Okay, so that is y equals x log to the base e x. There we go.